the angle measurements, etc. So today we're just going to start with basically Algebra 1 content, which is writing ratios and solving proportions. So a ratio is an expression that compares two quantities by division. It's a fraction. Sometimes they also write it in ratio notation. The ratio of A to B is read the ratio of A to B. The ratio can be written as a ratio or a fraction. Fraction's usually the easiest because you can then reduce it and leave it as a fraction, but if you want to write it in ratio form, you can. So 3 to 4, the ratio of 3 to 4, or 3/4. Those are the same thing. So the first one asks us to write a ratio based on the word description. So a model car is 4 inches long. The actual car is 15 feet long. Before I move any further, what do I notice as a problem with those two statements? Noah?
Different units.
Good, they have different units. In order for you to write a ratio, they must have the same units. So we either need to convert 4 inches to feet or convert 15 feet into inches. Which one's the easier one? Usually. No? Good, feet into inches, because this one's going to get you a fraction of a foot, and most of you don't like to have fractions. So for 15 feet, remember there are 12 inches in 1 foot, so we just have to multiply by 12. What do we get? My apologies. What do we get? How many inches? Marquise? 100 what?
80.
Okay, so what is the ratio, and this is the part you have to pay attention to, of the length of the model to the length of the car? So I've already set it up for you, but normally that won't be there. So you want to make sure you put them in the correct order. The 2 is like where you would put the ratio symbol or where you put your division bar. So you want the length of the model on the top, and you want the length of the actual car in the bottom. And what will that reduce to get us? Joseph? 1 to 45. So just filling our blanks would be 1 to 45. You wouldn't want to have 45 to 1 because that's the opposite ratio, so just be careful. All right, a proportion is where we actually take two ratios and we put an equal sign in between them. So we'll have a fraction equal to a fraction. So it's a statement that divides two ratios are equal. Example would be equivalent fractions. 6/24 equals 1/4. So you can have all numbers. You can also have variables. So like x over 3 equals 5 over 2. This is more so what we'll be seeing today and also tomorrow with our similar figures. Now an extended proportion is when you have 3 or more ratios that are equal. An example of an extended proportion would be this. 6/24 is equal to 4/16, which is equal to 2/8. We could also extend that and say that that's equal to 1/4. So sometimes you will see ones where they ask you to find a missing value in an extended proportion. You can either cross multiply multiple times, which we'll talk about in a minute, or you can always reduce. Let's suppose this had an x in it. You can reduce the ratio that gives you both of them to its simplest form, 1/4, and then think, how can I get the denominator 4 to become 16? Well, I'd have to multiply this by 4, so I'll multiply the top by 4 to get your answer. So they're all equivalent, but sometimes they're not, it's not like directly divisible by a number to get there. All right, common proportions. If we have A over B is equal to C over D, we can also cross multiply those to get A times D is equal to B times C, or C times D, multiplication. You can also flip both sides of the proportion. B over A is equal to D over C. You can actually also rewrite it so that it's the top over the top and the bottom over the bottom. So A over C is equal to B over D. If you check, the cross product is always the same. AD equals BC. AD equals BC. So these are all equivalent. They're just different ways that you can write it. And then the last one is actually a sum, where if you take the top number plus the bottom number, so the numerator plus the denominators, keep the denominator the same. On the other side, you have to do the same thing. It's like a pattern. On the other side, we also have to take the numerator plus the denominator over the denominator. And again, if you wanted to, you could cross multiply, get all your variables solved around, and you would prove that it is still equal to your original cross product. So the bottoms ask us to complete each statement based on the given, and they're in conditional form. If something, then something. So you're basically just following the pattern of what is going on. So if x divided by y is equal to 5 over 6, you can actually let that be that x equals 5 and y equals 6. That might be the easiest way to think it. If x equals 5, then y equals 6. Then what is x plus y over y? Well, if x is 5, we'd have 5 plus y is 6 all over y, which would be 6. And then we could simplify that if we want to, and we could get 11/6. Or you could have noticed the pattern. It was to add the numerator to the denominator, keep it over the denominator. So go to this fraction, numerator plus denominator, keep the denominator, however you like to do it. Okay, and the next one we have A over B equals 4 over 3, so that would be A equals 4 and B equals 3, just looking at the equations. Kind of just substitute those values in. A is 4, B is 3, so 4 plus 3, and now we get 4 sevenths. See if you guys can figure out the next two, which are a little bit harder. At least C is. See if you can figure it out. So this one is going in the reverse, like if they give you this, working back to this. So they're saying the numerator plus the denominator over the denominator equals the numerator plus the denominator over the denominator. So this would be just D over 7. If you didn't see that, you can actually cross multiply. You would have to put parentheses around this. So you would get 7 times C plus 2 equals 2 times D plus 7. And then you would distribute and do a whole bunch of work, but you would end up solving whatever C divided by 2 is, and you will get D over 7. And then how about D? What do we get for that one? Marquise? Say again? 1. No. Katie? Yes. So looking at the pattern, we have A over 4. So they're saying A over 4, you follow the same pattern, it will be B over 5. So some of them are going to be as straightforward as just substituting in. Some of them you're going to be looking for a pattern amongst them and following that pattern for either the numerator or denominator. Okay, on the back we have a couple of the extended proportions, which every year some students find these very difficult. I don't know why, but they do. You will always be given at least one fraction that is complete, a numerator and a denominator. There are two ways that you can solve this. One of them is to put variables in, like x and y. Put different variables in. And you can cross multiply 2 times. So one of the equations you would cross multiply would be 6/8 equals x 20ths. And the other one would be 6/8 equals 24 over y. And you can cross multiply both of those and get your answers. But you want to make sure that you don't cross multiply when you have two different variables. It's not possible to solve. Okay? Now, another way you can do it a little bit more mentally without having to multiply 8 and 24 in your head is to take the fraction that they give you and reduce it, if possible. What would 6/8 reduced to be? 3/4. And then you can literally just think in your head, if I want the denominator to become 20, how do I make this become 20? Well, I'd multiply it by 5, which means I'd have to do the same to the top, which will get me 15/20. So x would be 15. Do the same thing. We have 3/4 has to be equivalent to 24 over y. Ethan? I don't have any. I'm going to go the rest of it. What do you think y would have to be? How do we get 3 to become 24? Multiply by 8. So 4 times 8 would get me 32. If you don't like that, just do it 2 cross multiplications. 8x equals 120, divide by 8, you got your 15. 6y equals whatever 8 times 24 gets us, and then divide and you will get your answer. Try the next one on your own, either using the reducing method and then equivalent fractions, or cross multiplying 2 times. See if you can get this one. Cross product property is just talking about what I've been saying, the product of multiplying diagonals. So there are vocabulary terms for this. It says the product of the means is equal to the product of the extremes. We're going to learn a little bit more about that later in chapter 7 in regards to our similar right triangles. But A and D are considered the extremes. B and C are the means. You don't have to know these words yet, really, but all it is fancy terminology for cross multiplying, which is diagonal multiplication. You multiply the numerator times the denominator of the other. Make sure you bring the equal sign. So that would be A times D equals, make sure you include your equal sign before you go the other direction, B times C. And that's our cross product property, which you've also learned in Algebra 1. So below we just have some examples where we're asked to solve for the missing term. And sometimes you don't have to cross multiply. You can use equivalent fractions. For this one, personally, I would say, well, 5 times 7 is 35. So 2 times 7, n is 14. You don't have to cross multiply. But if you were to cross multiply, we would have 2 times 35, which gets me 70. But I'll write the workout for right now. Equals 5 times n. 2 times 35 again is 70. And you solve using inverse operations. Divide by 5, divide by 5. We get our answer, which is n equals 14. But obviously, sometimes it's easier to do it without cross multiplying. Now, when we see, what is this called? When you see two numbers being added, or a variable and a number being added or subtracted? What type of polynomial is this when it has 2 terms? Lexi? A binomial. Anytime you see a binomial or a trinomial, you have to put parentheses to group it, so that whenever you cross multiply, you remember to distribute. So I will cross multiply this one because I don't see necessarily the pattern of what's going on. So I would have 4 times y plus 3. Bring down your equal sign. Multiply the other diagonals. 8y. And then you would just solve using algebra skills. Distribute. get your variables on one side using inverse operations. And use inverse to divide. Now if you really wanted to, you could plug them back in and realize that 3 plus 3 is 6/8 and 6/8 is equivalent to 3/4 if you have the time. Make sure you did it right. Alright, due to time constraints, we're going to skip the next one because it's almost the same thing. If anyone did it, you do get n is 3. The last thing is our scale drawing. So a scale drawing is basically a map. Any of you that had Mrs. Jugka, I know you had maps all the time because she was borrowing my rulers for your maps. A drawing in which all the lengths are proportional to the corresponding actual lengths. So on the maps, they give you that little key that tells you 1 inch represents however many miles or kilometers or whatever. And that's called our scale. So the scale is the ratio of any length in the drawing to the actual length. This says maps are scale drawings. Now, when you do the maps, you don't have to convert all the units. You don't have to convert miles to be inches, okay? What you're going to do is they're going to give you some information. 2 cities are 3.5 inches apart. The scale is 1 inch represents 50 miles. Find the actual distances. So what you're going to do is you're going to write a proportion. The variable will be what you want to find, which is x equals the actual distance between the 2 cities in real life. This scale is going to be one of your proportions. I would use units, 1 inch over 50 miles. You do not have to convert these because you are going to have something equal to something that is also in terms of inches and miles. You want to stay consistent. You can write this differently if you want to, but I like to put it exactly as I see it. And then you want to make sure that the top has inches and the bottom has miles so that they're exactly equivalent in their size. So the 3.5 inches would go in the numerator. The x would go in my denominator. And then you just cross multiply. So we'll cross multiply, we'll get 1x equals 175. Of course, you could divide by 1, and that would be 175 miles. See if you guys can complete the closure, just filling in those blanks. They should all have numbers and variables in them. While I pass out your homework.